Hello everybody. Today we move on from piecewise functions and we go to absolute value functions and how absolute value functions are transformed. Well, first thing, absolute value functions are very similar to quadratic functions. So they're very similar to parabolas. And you'll see that in a second here. I hope you remember them from maybe 8th and a bit of 9th grade. But absolute value functions look like V's. Not the U of a parabola, but a V. So it looks something like that would be your parent function for absolute value functions. Your parent graph for absolute value functions, I should say. Now, of course, that graph, just like a parabola, can move. It can move left, it can move right, it can move up, it can move down, it can flip over the x-axis, it can flip over the y-axis. So many different directions it can go. And if you remember back from parabolas, this should all make some sense because our A, our H, and our K essentially do the same things that they used to do when they do the same things that they do when we studied parabolas. First of all, the A value. If the A is negative, that is a flip over the x-axis. It's a flip over the x-axis. So you're reflecting across the x-axis if A is negative. All right, if A is between 0 and 1, that's called a shrink. And a shrink is when the graph gets wider. So over here on this graph, let's change colors to green. And a shrink, if this is the parent function in blue, a shrink might look like this, where the V gets wider. So that would be a shrink, and that's when the A is between 0 and 1. Okay, now if your A value instead is greater than 1, that's called a stretch. And a stretch is when the graph gets thinner. So let's change colors here one more time and go with, well, I guess we're going to try, I guess that's red. And if we had a stretch, if the blue is the parent function and the green is a shrink, a stretch would be up here. It'd be narrower than your parent function and look something like that. And again, that is if A is greater than 1. Or your H value. Your H value that sits right in here. If that value is positive, we move to the left that many spaces with our vertex. If the value is negative, we move to our right that many spaces with our vertex. Lastly, we have the K value. The K value is the number outside of the absolute value bars, whereas the H is inside the absolute value bars. So with the K is pretty straightforward. If it's a positive K, the graph moves up. If it's a negative K, the graph moves down. All right, now the good thing with these absolute value functions, if it's in standard form like you see here, the vertex is always very obvious. The vertex here is always HK. So H, the opposite of what you're going to see in here, because this is the opposite of H you see here. So the opposite of what's in here plus your K value from out back. It is H and K. So let's look down here at these problems, number 1 through 4. Are transformations. And Mr. Matthews is talking in the background. We can overtalk him. So here we go. First of all, we have a value inside the absolute value bars after the x. So because that value is positive, we move to the left 1 unit. Oh, my board was messing up there. Left 1 unit. Now we have a K value out here. That value out here is negative, so we would move down 3 units. It's that easy. That's the transformation there caused by your H and your K. All right, problem number 2. I have a negative out front, so I'm going to flip over the x-axis. So now it's going to be pointed down instead of pointed up. There is no number after the x inside the absolute value bars, so we don't go left and right. We do have a k value out here, positive 4. It moves us up 4. I'm sure you're getting the hang of this by now. For number 3, we have a 2 out front. So that's going to be a stretch. A stretch by 2 is the way we say that. And we have a number after the x in the absolute value bars. So that means we go left or right. Well, we see that negative, we think, okay, I got to go to the right. But there's a negative out in front of the x. So both those negatives put together actually give us a positive 1. So instead of going to the right 1, it actually moves us to the left 1. A little confusing? Hopefully you understand. Alright, and looking at problem number 4. Number 4, we have a fraction out front. So we have an a value between 0 and 1. So we have a shrink. A shrink by 1 over 3. The positive value inside, after the x inside the absolute value bars, means we move left 2. And the plus 3 out front means we move up 3. Alright, let's move down to problem number 5 and 6. We now have to graph the absolute value based on our transformations. We can do that. First of all, our vertex. Let's get our vertex for number 5. Our vertex, remember, is the opposite of what's in here in this. Our vertex is h and k. So our vertex for this problem is positive 1, negative 4. So let's go graph that. Positive 1, negative 4. There we go. And we are opening up here because we don't have a negative out front. We're opening up. Alright, well, let's go ahead and graph this. You really only need 2 things when you graph this. You need the vertex and you need the a value, because the a value tells you how wide or how narrow it is. If the a value was 1, that would be your parent graph. It would be up 1 over 1, put a dot, up 1 over 1, put a dot, draw the lines. But here our a value is not 1. Our a value is 2. So when you see an a value of 2, you know that's a stretch. So you go up 2 over 1, like it was a slope. It's really not, but same idea. Up 2 over 1 there, and we draw the graph. Here, arrowheads saying it goes on forever. Here, arrowheads saying it goes on forever. And we're done. We're done with the graph. Let's get the transformations in here. We have a stretch by 2. And we can see this vertex is shifted to the right 1 and down 4. So from the parent function right here, where the vertex would be 0, 0, right 1, down 4, a value of 2, there we have it. Looking at number 6. With number 6, let's do our transformations first. We have a negative, so we flip over the x-axis. We flip over the x-axis, so now it's going to be opening down. We have a positive in here, so we go to the left 2, and we go up 3, and that's reflected in our vertex. Our vertex is the opposite of what's in here, negative 2, comma 3. Negative 2, 3. There's my vertex. Now my a value is negative 1. So down 1 over 1, down 1 over 1, kind of like a slope, but it's happening in both directions. So there is my graph. Pointed off in that direction, and also pointed off in that direction. Okay, great. Let's go down to number 7 and number 8. See what's happening there. All right, number 7 and number 8, we're going to write the equation given that we have a graph. Easy enough to do. Let's do it. First of all, what's my vertex? Well, my vertex is that point right there, easy enough. So we know that vertex is 0, negative 3. 0 on the x-axis, negative 3 on the y-axis. So this is my h, and this is my k. All I need is one more thing, which is the a value. I'll know my three values, a, h, and k, and I can write my equation. So what is our a value? Is it 1? Do we go up 1 and over 1? No, up 1 and over 1 is not on the graph. But up 2 over 1 is on the graph. Up 2 over 1. So my a value is 2. 2 over 1, or 2. So very good. There's a, there's h, there's k. I can write the function. I'll write it down here, give myself more room. A value 2 out front. Absolute value bars. The h is 0, so all I have in here is my x. Absolute value bar again. K minus 3. Done. F of x equals 2 times the absolute value of x minus 3. Okay, let's do the same thing over here on problem number 8. Number 8 we see, let me move this over a little bit. We see that our vertex is right here, and that vertex is at negative 2, 4. Negative 2, 4. So that's our h, that's our k. The opposite of that number, negative 2, will go in the absolute value bars, and 4 will go outside the absolute value bars. What's our a value? Well, let's see. Up, down 1, oh, we know it's going to be negative, so down. Down 1 over 1 isn't there, but down 1 over 2 is a point on the graph. Down 1 over 2, down 1 over 2 in that direction. So we're at negative 1/2. This is a shrink. This is wider than normal. So there we have our three values. Let's write our equation. We'll do it up here. F of x equals negative 1/2 up front, absolute value bar, x in the opposite of what's in here, so x plus 2 into my absolute value bar, plus 4. And there we have it. Okay, hello, back again. You probably didn't know I was gone, but through the magic of video recording, I just stopped and went to Barbaritos, and it was wonderful. So now I have the strength to move on with the backside. Okay, so backside here, we have two more equations. I'm going to ask that you stop now, pause the videotape, and try these two yourselves. So please do that now. Alright, hopefully you are done with those two. Hopefully you pause the tape and aren't just deciding to listen to me ramble on, but you'll do what you'll do. Alright, here we go. We see our vertex is right here at 2, 2. The vertex is 2, 2. So that, of course, is my h and my k. My a value, up 1 over 1 is part of the graph, up 1 over 1 is part of the graph. So my a value is 1. So that should be easy enough to write the equation for. F of x equals, a is 1, so it's nothing out front, absolute value of x minus 2, the opposite of h, plus 2, which is my k. So f of x equals the absolute value of x minus 2 plus 2. Okay, moving on to number 8. My vertex on number 8, vertex is negative 1 and negative 3. So there's my h value, there's my k value. Now let's find our a value. Well, when I go down 1 over 2, I find a good crossing spot. Down 1 over 2. Down 1 over 2, that's 1/2. And we went down, so it's negative. So a equals negative 1/2. So f of x equals negative 1/2, absolute value x plus 1, the opposite of what we had here, minus 3 should be our equation. Alright, moving down, now we're going to solve a couple of absolute value equations. And you probably did this, I think you may have done this somewhat in 8th grade, but maybe not since then. I'm sorry, 8th or 9th grade, depending on when you had Algebra 1. Okay, here is how you solve absolute value equations. First, you have to isolate the absolute value. That means if there's something added outside of the absolute value bars or multiplied outside the absolute value bars, you have to get rid of that first. You just need absolute value all alone on one side and a number on the other side. So isolate the absolute value, then split into two separate equations. Split it into ax plus b equals c, or ax plus b equals negative c. Always check for extraneous solutions, so we'll do that as well. Alright, in practice, here is how it goes. So we have the absolute value of x minus 3 equals 6. Quite easily, we set x minus 3 equal to 6, and we set x minus 3 equal to negative 6. Absolute value bar is gone. Here, add 3 to both sides. X equals 9. Here, add 3 to both sides. X equals negative 3. Let's see if both those solutions work. If I plug 9 back in here, what is the absolute value of 9 minus 3? Well, 9 minus 3 is 6. The absolute value of 6 is, of course, 6. 9 checks out. How about negative 3? Negative 3 minus 3 is negative 6. The absolute value of negative 6 is also 6. So that answer checks out as well. All is fine. Okay. Number 10. Break it up into two pieces. 6x minus 3 equals 15. And 6x minus 3 equals negative 15. First step, add 3 to both sides. So 6x equals 18. Now divide both sides by 6. X equals 3. On the other side, add 3 to both sides. 6x equals negative 12. Divide both sides by 6. X equals negative 2. So we're going to check on both those. First, plugging in a 3. 6 times 3 is 18. 18 minus 3 is 15. And the absolute value of 15 does equal 15. That one checks out. Checking negative 2. 6 times negative 2 is negative 12. Negative 12 minus 3 is negative 15. The absolute value of negative 15 is definitely 15. That checks out as well. So both solutions work there. Okay, moving down to number 11. Number 11. Well, we got to start off somewhat differently this time because I have a value here. My absolute value is not isolated. In order to isolate it, I've got to add 3 to both sides. That gives me the absolute value of 2x plus 7 equals 11. So now we can break it up into two pieces. 2x plus 7 equals 11, or 2x plus 7 equals negative 11. Two-step equations. First step, subtract 7. 2x equals 4. Divide both sides by 2. X equals 2. We'll check that in a minute. Now plugging in, well, not plugging in here, but solving here. Subtract 7 from both sides. 2x equals negative 18. Divide both sides by 2. X equals negative 9. Well, let's plug it in and see. For positive 2, 2 times 2 is 4. 4 plus 7 is 11. The absolute value of 11 is 11. Minus 3 is 8. That works just fine. We can check it either here. Let me change my colors so you can see. We can check either in the original or we can check in the transformed. Probably easier just to check in this transformed. So let's plug in negative 9. 2 times negative 9 is negative 18 plus 7 is negative 11. The absolute value of negative 11 is indeed 11. Both of those answers check out just fine. All right, I want you guys to all pause the tape now, and I want you to try 12 and 14. Try 12 and 14. So please pause the tape now. Try both of those. When you're done doing them, turn the tape back on. All right, hopefully you paused the tape and have solved 12 and 14, leaving 13 for us to do together in just a minute. 12, you should have done, it should look like this. It's already isolated, so we do 2x minus 5 equals 9, and 2x minus 5 equals negative 9. Add 5 to both sides, 2x equals 14. Divide by 2, x equals 7. We'll check in a moment. On this side, add 5 to both sides, 2x equals negative 4. Divide both sides by 2, x equals negative 2. Let's check our answers. First, we'll check 7. 2 times 7 is 14. 14 minus 5 is 9. The absolute value of 9 does equal 9. That one checks out. Now trying negative 2. 2 times negative 2 is negative 4. Negative 4 minus 5 is negative 9. The absolute value of negative 9 is 9. That one checks out as well. All right, the other one that I asked for you to do was number 14. So let's take a look there. Number 14, it's already isolated, so we set up our two equations. 4x plus 10 equals 6x, and 4x plus 10 equals negative 6x. That's a little different. We have a variable over there. Let's see what happens. Well, this time, let's subtract 4x from both sides. That'll give me 10 equals 2x. Divide by 2, x equals 5. Well, we'll check that solution in a minute. Over here, if I subtracted 4x from both sides, I would have 10 equals negative 10x. Divide both sides by negative 10, x equals negative 1. Well, let's check our solutions there. If I'm going to plug in 5, 4 times 5 is 20, plus 10 is 30. The absolute value of 30 is 30. So 30 equals 6 times 5 is 30. So yes, that solution checks out. Now I'm going to check on negative 1. 4 times negative 1 is negative 4, plus 10 is positive 6. So the absolute value of positive 6 is 6, equals 6 times negative 1. Oh, that's negative 6. That does not work out. So this is an extraneous solution. So only x equals 5 on this one. There's our first extraneous solution. Good. Hopefully everyone got that. Let's pop over to number 13. I saved 13 for last simply because it was a little different. It's very similar to number 11, but instead of having something added or subtracted, we have something multiplied times the absolute value. So what do you think our first step is? Hopefully you all said divide by 2. That's what I'm going to do. I'm going to divide that side by 2 and that side by 2. So now I can divide out. The 2 goes away, and I have the absolute value of 2x plus 5 equals positive 11. Putting it into two parts. Move that out of the way there. First one, 2x plus 5 equals 11. Next one, 2x plus 5 equals negative 11. Subtract 5 from both sides. 2x equals 6. Divide by 2. X equals 3. We'll check that in a moment. On the other side, subtract 5 from both sides. 2x is negative 16. Divide both sides by 2. X equals negative 8. All right, shall we check our solutions? We'll check using the transformed. We'll check using that. So plug in 3. 2 times 3 is 6. 6 plus 5 is 11. The absolute value of 11 is 11, so we're all good there. Trying negative 8. 2 times negative 8 is negative 16, plus 5 is negative 11, and the absolute value of negative 11 does equal 11, so that one checks out perfectly as well. Alright gang, that is all for today's lesson. Tomorrow you will have a homework sheet where you will work on problems just like I've done here, so make sure you save this paper and have it ready for you tomorrow when I am off campus. Don't mess around, go ahead and get it done. If you need some review on this, if you forgot your notes, go ahead and open back up a Chromebook tomorrow and take a look, and hopefully you'll get all your questions answered. All right, thanks very much.